Okay, so we are quite fragmented, I can see. Definitely today I am going to tell you the problems with the fragmentation, but that's not good here. Okay, so that's fine. I mean, it's some people like backbenchers. I also prefer to be in the backbench. That's perfectly fine. Okay, but fragmentation have a problem in software engineering. We must be knowing that. Okay, so let's discuss. Are we expecting anyone else? Jayshree? Okay, she is one. All right, so I'm going to talk about the scaling up your Java application. Hoping most of them are from industry and very few college students I can see here. Okay. In fact, I have made my slides much easier for the college students to understand. So can be a trivial slides for you, but let's go through it. I am a JVM engineer. I was working in Sun Microsystem in 2005. I joined the hotspot team. I'm in the JVM team, and then I joined Oracle, and then right now I'm working in Salesforce, and I'm still a JVM engineer. Okay. What JVM engineer do is like it's a good tag name. Actually, they don't do anything much. So we just keep frightening people like things will not run good. You are not running right parameters, all those kind of things. I am Bangalore Jug leader from 2006. It's been quite long. And now I am grateful for all the people like Jayshree and Satish who have taken the Bangalore Jug. All right. So how many of you here are the Java developers? All of you? Okay. I mean, better question to ask how many of you are not Java developers, but fine. Okay, Java is kind of 1995. It's an old language. It's one of the oldest language. Not one of the oldest language, which is still doing great, but yes, it's one of the very old language. And Java is pioneer in many things, like the garbage collector. The garbage collector first came into the Java peripheral, and runtime optimizations first came into the Java, and suddenly Java is 1995, and till 1997 it became a very super hit language actually. Okay, and it's still doing good. I mean, most of the Python developers will not agree with me, but if you have a question like what are the things that a language get changed, so generally, we do lot of meetings and a lot of discussions with like processor developers like Intel and AMD. We do a lot of meetings with OS developers like Microsoft and Linux community and all those. And then we discuss like what are the problems they are facing. Okay, what are the supports we need from them as a processor level or from the operating system level. Okay, so they are all very highly integrated. Don't think like a language don't leverage the features which are there into the processor or the features which are there on the operating system. Okay, so we try to suck up the best out of everything. Okay. Yes, maybe I'm working in Java from a very long time, so that's why I can say like it's still one of the languages which is highly scalable. Okay, and there are many examples of that. I mean, I remember like Twitter when it started, it was started with a very small application, and slowly they need to go for a very high level of escalation, right? And they moved on Java. Actually, I don't want to say that what language they had before, but when they were not able to scale up the application, they moved later the language on Java. Okay, so very easy to scale a language like Java. Okay, and Java future, I really don't want to comment much. Okay, but it looks solid still. Okay, so let's this session will get interactive. Okay, and we will discuss actually. I have only 45 minutes, but still we want to discuss. So application scalability is one of the biggest challenge that industry is seeing. Okay. And many people here who work like for big applications like e-commerce, anyone who is working in Flipkart or Amazon or Salesforce or any of the big e-commerce application, you can understand that how troublesome it is to scale the application. Okay, so I want to hear from you. You need to be loud. That say like okay, this room can fit like maybe 500 people. Okay, what will happen if I try to fit like 5,000 or 10,000 people in this room? I mean, it's just a scaling problem, right? So I want to know from anyone of you.
Suffocation.
Suffocation. Yes. That's right. Where people will sit actually.
Overloading.
You will fight with each other. Okay.
Overloading.
Overloading. You guys have learned object-oriented language. What is that overloading? Okay. Anything else? Out of space. Out of space. Yes. Anything else?
Movement of people within the normal time.
Movement of people within normal time. Okay. Okay. Yeah, with all this problem, we will not able to solve the purpose. Okay. So this is the same problem. What happens that you started with some website or some Java web application, and you are like 100 customers right now. Tomorrow it will be 1,000, and soon it will become millions and millions, right? And then, like all the government sites, you will see that sites are not running, and you are hitting 404 and all those kind of things. Okay. So, scalability can be done by many ways. The first, it should come by design. And a lot of people I see, Murli was also talking about the design and the programming language and data structure. So, design is one of the most important things, which comes in a very early phase. You need to believe yourself that tomorrow I am going to have millions of customers. Okay. If your mindset starts with like I am going to have 100 customers, then it's fine. No one can help you out. Okay. And the second thing is that development, which is like the coding part, which we are going to discuss a little bigger, like how the coding changes the scalability of the application. The third thing is optimizations, which is provided by the complete stack from processor to operating system to language to your framework to your programming language. All do optimizations at their own level. Okay. And they all try to do best and they try to run your application the best. Okay. And the last is infrastructure. Okay. And infrastructure is the last resort. If you will say like, I want to scale this application and I am going to make this room large and I am going to add more seats into that. And people will reject your solution. They will say, no, that is not possible. Okay, I cannot make this room large. Fit 5,000 people here only. Okay. So we will discuss about infrastructure and we will discuss when to increase the infrastructure. But if you will directly go to someone and say like, I need more CPU, I need more RAM, I need more heap, they will straightforward reject your application. Okay, the first three parameters you have to fit perfect. Yeah? You have any questions, you can ask me anytime just by raising your hand. Okay, so solution by design. Let's understand very few basic things. I am not going to be too technical here. So one of the best design solution is loose coupling or no coupling, right? I mean, one of our engineers said that we will disturb each other. Something you were saying, right, sir, that we will disturb each other. Okay. Now you need to be loose coupled. You need to be a zero coupled. I mean, you should not disturb the nearby. Then you think that we can fit more people here, right? So loosely coupling is one of the solutions. If you are not disturbing the person next to each other, or your code is not disturbing the code next to each other, you are perfectly fine actually, right? So loose coupling has many benefits. You know, multi-threading, you can apply as much thread as onto the loose coupled code, right? So and that's called the art of being stateless. Okay. So stateless means like we all need to be stateless actually. Just finish your work and keep going. Don't try to put something which is not required into the memory, into the database. Don't try to save the state. Don't try to pass the arguments unnecessarily from one place to another place, right? So you know it's a very strong review system that can figure it out. Okay. But generally for the review we look for like shortest distance people, right? So we just tell the next bench guy that can you review my code. and right, we will just go and press a button. Done. Okay, so that's not how the industry review happens. Okay, we have worked in OpenJDK, and it's too complex to get even a small trivial code to be reviewed in a JDK world. Okay, I mean they will just bomb blast you with like 10 times more than what you have written in your code. And what I wrote is that your architect or whoever is the designer of your application need to remind the team every day that your review system should be good. Your code should be stateless as possible. Okay, it is not possible to be stateless all the time. Yeah. Fault tolerance, right? So I have given an example. Like, what will happen if a transaction fails? Say like you are making an e-commerce system like the Amazon, and the transaction fails. What Amazon system should look like? Any answers?
Intuitive.
Please.
Intuitive. I mean,
Intuitive. Okay. Intuitive means the transaction has failed. Sorry for the inconvenience.
and the next step.
Huh?
And the next step.
Retry. Retry in the statement or actually?
Roll back.
Roll back. Oh, you are still into the database world. That is gone long before. Okay. That is like 15 years before. There is no roll back and all concept is gone now. Okay. Now we make sure that we sell the same item to two customers. Okay. And then one we return the money and one we give the item. Okay. We are working on different levels. Please, louder. Compensation. There is no those minds are right. Okay. You can take this. Yeah, Firoz is there to help us. And Firoz is
Audience with
another
the laptop.
engineer.
Just tell us. Kalesh, onchೂರು cable release ಮಾಡಿ. No single point of failure.
Okay. Audible? Yeah. Thank you. So basically what I was asking is from the coding side that what if the transaction fails? What if the download fails? What if the connection socket fails? What you should do? You should have a fault tolerance and that is called retry. Okay. So most of the applications that we develop, actually if there is a download that fails, it will retry. It will retry for 2 times, 3 times, 4 times. Okay, there will be a threshold set for that. Okay. Intuitiveness is gone. It's a long old history that I cannot just tell that, oh, this download failed, you need to retry it again. Okay. So we need to write a code or we need to write a script which will be fault tolerance. Yeah? The last part which is very important is modularization by design. You all know the module systems, right? So modular codes are it's very tough written in industry. Most of the people, I mean, they just talk in the theory. They don't really write a module code. But the good framework actually force you to do so. Okay. So people who use lot of frameworks to develop like Spring Boot and all, the modularization and all will be a framework forced to you. Okay. And what is the meaning is that one module input and output is good enough for the another module. Okay. I am not really going that way, what you have written there. Okay. So it's like, okay, this is the input of this guy, this is the output of that guy. Other guy should just see the output of that particular module. Okay. Don't try to go inside what it is written. Yeah. So these are the few solutions which are by design. You should try to make your application. I mean, you should think before even start writing code for your application. You can ask me question anytime. Okay. This we are going to talk a little bit more. So solution by code or by development or by whatever you want to say. Okay. So we are looking here for the solution at like all the software life cycle, and we will see that how they can solve. So right, by code, anyone, I mean, don't see the slide, that how you can make a scalable application. I mean, today you have 100 customers, tomorrow you will have 1 million customers. Who was that person? Multi-threading, yes, multi-threading.
Asynchronous?
Algorithm should be optimal, yes. Okay. Load balancing, who said that? Okay. Load balancer is actually an infrastructure thing. It's not a coding level, yes. But yes, load balancing is one of the important things. Anything else?
Data structures and algorithms?
What in the data structure and algorithms? I generally get scared when people say data structure. I remember all my interviews. Okay.
Like the choice of
Concurrency, yes, that's right, multi-threading concurrency. Okay. Really, no one is for parallelism here. I mean, concurrency is a beast, it's a very complex thing. I mean, parallel things are much easier, right? Is it not so? I mean, in place of one door, I will just open the 4 doors and I will tell people to come inside. Is it not so? Concurrency is not so easy. Concurrency, I have to put a guard there and I have to tell that, man, if someone came inside, you should just close the door. Okay, so concurrency will come later, but parallelism come much before the concurrency, right? So one of the solutions, the best solution is like, you should write parallel code, which is multi-threading, precisely one of the gentlemen have said here, right? And the multi-threading, there are many ways to do multi-threading in most of the language, but most of the language you should leave onto the standard APIs to do multi-threading, okay? I mean, you really don't have to go and discover the whole wheel again, that I will write my own multi-threading code, okay? I will show some of the example, like I will just take like Java example and say like I will run a simple streams into the Java and I will just do dot parallel and then you should see how the parallel streams work, right? And it's a pure one word of code change to make it multi-threading, right? And parallelism, you should know that the data on which you are working, first of all, that data need to be splittable, right? Like people entering into this hall, is this data splittable? Yes. Because you all have to occupy different seats, right? Doesn't matter that you are entering from that gate or that gate or this gate or this gate. I can just open all the gates and I will say that, come inside. So, in programming language, I will say like make 6 threads, where all the threads represents a door, right? Just go inside. I mean, if you are sitting on each other, then it's a different problem, but should not happen like that. Okay? So, let me run a simple code. Is it visible? Okay. So all the people who are like from the Bangalore, these codes they have seen like 100 times and must be very boring for them. But what I am doing is that I am doing little bit complex calculation where I am finding the area of circle. So math.pi, A equal to pi r square, right? And then what I am doing is that first block I am putting it into normal stream, and in the second block I am adding it into the parallel stream. You can see here. Let me dark it for you, right? And I am also posting that how many number of processors available on this machine. Okay, so that you can guess the timings. So here it goes. Run. So, oh, this is not visible, is it? Okay. So, my machine, which is a company box, that's why it has 10 processors. Okay. Generally, corporate give a very good laptop. So, So, output is same for both the values. Like, you should not get confused. I mean, that is 3.591 something is the output. And you can see if I'll go sequential, then it has taken 3074 milliseconds. Whereas when I ran it parallel, it took like 392 milliseconds. Can you tell me what fraction is that? Is it 10 fraction? Really? No. Don't be so confident. If it is 10 fraction, it should be 3920, the upper one, right? Okay. Ideally, it should be 10, but there is nothing called ideal in the real world. Okay, so almost like 8 times better job, right? With 10 code. And you should not be sad that, oh, where the 2 codes are going. Okay. There is a lot of management work that parallelists have to do. Okay. So why I showed you this code is just to say that parallelism is very simple. Okay. And where it used, we almost use everywhere into the modern industry, right? The Hadoop, you are doing a lot of background jobs like scanning the paper or doing a lot of cron jobs. Everything use actually parallelism. Okay. Any questions? Everything is very simple, I can understand. So, if you are again parallelism very properly, then you should come on to the concurrency, which a lot of people said, right? And concurrency is little complex. Anyone can tell me the difference here between a parallel application and a concurrent application? Not the Bangalore Jug users. And concurrency need to be seen. Okay. Race condition, yeah. Okay, then concurrency need to be used. Something more, straightforward. It's still very complex definition. Yes, if you are sharing resources, it is concurrency. Okay. That's right.
One is independent execution and one is dependent.
Right. So actually what happens is that when you are running similar kind of threads or similar kind of work, that is called parallel execution. And when you are running different kind of work into your processor, like your 3 threads is doing different work, your 2 threads is doing different work, that is concurrency. This is at the very bottom level. At the top level actually, when you are using a shared resource and you are trying to get into the shared resource, you need to use concurrency. It's very simple. Okay. So as Sir told, like concurrency has a lot of waiting time, and any guesses that why there will be a waiting time for concurrency? Logs. Okay. Logs, yes. Okay. And what if will not log? Race. We all like race, right? What is the problem? No? Okay. Okay. Data corruption? Can I say? Yeah. I mean, in the end, you should say something which is quantifiable. Okay. You should not say race condition. It's not quantifiable. What is the final effect is that data will get corrupted, right? Your bank balance will get corrupted. Okay. So concurrency generally deals with a very complex formula. Actually, it's not so complex, but if you try to understand. Okay. Concurrency is basically concurrency or parallelism is get impacted by 2 things. Okay. One is called the computation job and one is called IO job. Anyone have doubt about it? What is computation job and what is IO job? Computation job is like purely mathematical job, like what I was doing in that code, like finding A equal to pi r square, right? And IO jobs are like connecting to database, connecting to the HTTP client, okay. Anything where the IO is required. When IO is required, actually, what happens that the CPU says that I am free now, okay. There is no load onto the CPU because it's like a background job or it's a less priority job, right? So CPU will be free for most of the time. Okay. So how to deal with that? Application is too complex. You don't understand like which jobs are computation jobs, which jobs are IO jobs. So you need to figure it out. Okay, you need to figure it out. That do my image is all about. Do my application is all about image processing? Yes. If your application is all about image processing, it's a high computation job. Okay, image processing is a total computation job. All right. Is that I have to save image to the disk? That's a IO job. Okay. Is that I have to go and take the request from somewhere? It's a IO job, right? Now, who know your application? Definitely I am not. You know your application, right? So you need to figure it out that what are the IO jobs available, what are the computational jobs available, and then how to manage the number of threads. Okay, here I have given you an example. Don't get into the details, but number of thread creation depends upon how many cores you have. So say like my laptop had 10 cores, right? 10. Into utilization, how much CPU you want to utilize? Should we utilize 100% CPU? No? Yes? Why you guys are so embarrassed saying no? Yeah, no. I mean, I really don't want to kill the CPU. If you are using 100% CPU utilization, your CPU will like burn out. Okay? So yes, every industry have a standard set like 40% or 60% of CPU utilization. Okay, if there is a more than 60% of CPU utilization, they will have a red flag. Okay, I mean, we have a whole team who is sitting and just watching this all things. The time it will go to 60% doesn't matter, it is 2 o'clock midnight, you will get a message. Okay, that your application is not doing well, you should also not sleep now, wake up. Okay, so those things are like part of job, nothing to worry. So I will take 60% of utilization. Now 1 plus wait time divided by compute time, it's very simple, right? Like the whole idea is computation. That means your wait time is 0, computation time is 1. So whatever is your core, just create that much number of threads. Depending upon the utilization, I am taking it 100% right now. Not true. If your wait time is very high, say like it's your wait time is infinite, how many threads you need to create? Whatever you create, it will not be fulfilling, right? Your number of threads need to be infinite if your wait time is infinite. Your CPU is kind of always empty. So what happens? It will be somewhere in between. 60% computation, 40% IO work. Okay. So on all these values, you should create the number of threads. You should run your application. You should try with some more data. Okay. And then finally, you have to reach to a solution. We language developers cannot provide a solution for you. Why? Because we don't know the application server. Okay, I mean language developers have just developed a generic solution for you, right? So you saw that parallel stream I ran right now where the Java thought like it's a computation job. Let's take all the CPU and use it. Okay, so you saw the application running like 8 times faster or maybe 9 times faster. But that is not the truth case in most of the industry. You just want to run 4 times faster or 5 times faster. Yeah. Okay, and the last line is like theory is just a start point, right? So you have to do the work to believe. Any questions? Any doubt? Okay, good. So what happened that this was kind of synchronous model where like when you start doing IO job, actually your thread will be blocked. That is called blocking of a thread, right? So we will say like, boss, this thread is blocked. Let's put other thread for the job. Okay, and that's why the number of thread need to be higher when it is a blocking work, right? So we came with the concept of asynchronous threading. Okay, asynchronous thread modeling is like think like a restaurant, right? When you are into the restaurant and say like waiters are there are some 10 tables, right? Now I will send a waiter on one table and I will say like, boss, still that guy will not give order, you stay there. It's a blocking, right? You are just wasting the time of the waiter, and here people are chit-chatting and they are checking their WhatsApp and they are like saying, hey, this item is not good, this item is good. Someone will say, let's order this. Someone will say, no, we will not order this. And that waiter is like seeing your face. Okay, so that is typically how the synchronous system works. Okay, you are blocking a resource. You are blocking a very valuable resource. I mean, waiters are valuable resource in terms of restaurant, right? So asynchronous thread model say that you just go and attend the problem and then say like, you guys decide till the time I will come back. Okay. But the problem is that someone else can come back. It will not be you who will come back. So those threads which will be empty will come back, right? So that's the asynchronous model which is very good, very effective, but there is some problem into the asynchronous model. Anyone can vouch for it? Okay, that's a very good point. Anything else? So you are saying that thread need to communicate between each other, yes? It will come back or not come back, that's a problem. Very good point. Yes? Anything else? Stateless. Can you please elaborate? Exactly. Very good. Starvation, yes. What he said is precisely starvation, that the thread will come back or not. I mean, that's a question, right? There will be, I mean, yes, you can say the most of the thread will be like leaving the job and like they are just idle. Okay, possible. Okay. Yes, so the biggest problem with asynchronous is like the same thing what happens into the restaurant, right? Like you explained something to the first waiter and then the second waiter came and I mean, you will tell like, I already told you this and this guy will like, no, tell me from starting. Okay, so there is a callback mechanism, right, where the thread need to communicate with the next thread. Okay, and it becomes complex. And you know, in the software industry, we say something like thread dump. You guys know, right? Thread dump. Thread dump becomes very complicated because it is not one thread which is dumping it, right? So on your particular problem, actually, there are 4 threads who have worked on. So now I need to get the thread dump of all the 4 threads. So the debugging becomes very, very challenging. Okay, because you will not understand that what is going, which thread is attending the problem where. But in the end, actually, the application performance will be better. Okay, but if your application will go bad or go down, you should be ready for your weekend job. Yeah. Okay. So in Java recently we did something extraordinary. That is, we say that the JVM said that we will handle the asynchronous model. Okay, so programming language don't have to handle. By the way, there are a lot of frameworks came in between this asynchronous model and the new thing which came into Java. And those all frameworks or programming model actually say that we will create asynchronous model for you. You really don't have to worry. Okay. Now Java or JDK itself claim that you really don't have to worry. Okay, so they called something called virtual threads. Okay, where the Java is saying that we will create the thread and we will see that how to synchronize and asynchronize the thread. You don't have to worry. Okay, and the thing is that you have to just change one line of code. In place of thread, you have to say virtual thread. That's it. Okay, and the performance will be damn better actually. What we are still not into the production mode, we are still like into the multiple testing modes. So, but I have few small codes where I can show you the performance. Right. So it's visible, and right now I have said that virtual thread is false, right? And I am creating kind of 5 lakh threads. I mean, you guys are comfortable with lakhs and all, right? Not the million billion guy. I feel a lot of people feel very embarrassed saying like lakh and crore. I mean, it's fine. It's our nomenclature. You can say that. Okay, don't be so embarrassed about it. So I'm not using the virtual thread right now. It's false, and we are creating kind of 5 lakh threads. Let's see how much time it takes. And I have given some kind of small work for it to do. Okay, nothing much to worry about it. So yeah, sorry for that. I have not written milliseconds. So it took like it took like 15 seconds, 15616 milliseconds. Okay. What I will do is that I will say like just run with the virtual threads. Okay. Means now it's not the operating system thread, it's the JVM threads. Okay. Yeah. Okay, and now you can see, oh, this screen is visible. Now you can see it took like 1 to 1 millisecond if we are creating virtual threads. Okay, so you can understand it's a massive difference in the time. Okay, and now these threads will take care, and you really don't have to worry about that how the JVM is doing. If you are finding any problem, just throw it to the JDK guys; they will fix the problem. Okay, and definitely you have to pay them. You can use open source JDK, yeah. Then you have to fix yourself. Huh? Okay, so this is one of the benchmarking we did with the virtual threads, and you can see in the normal traditional thread when the concurrency is going from 100 to 200 to 1000 to 2000. Now the transaction per second is not increasing after a certain limit. You are seeing it is becoming 199 and then let it be 1000 thread or 2000. In fact, the 2000 thread, the transaction per second is reducing out because your system is not capable enough to handle those kind of threads. Whereas if you see the virtual threads, you can see the TPS is continuously increasing even if I am creating the number of threads much higher than what it is required, right? Okay, so don't ask me that, okay, what is the drawback of this? Okay, that you have to go and figure it out. Last time I remember I was giving virtual thread presentation somewhere and he said that, no, you cannot get all these things in free now. What is the drawback of this? Okay, no drawbacks. No, that is not possible. Okay, so here are the things we discussed the solution by code. So you should be good in parallelism, you should be good in concurrency, and there are many good things, writing good code and all those kind of things. I'm not going to discuss the good boy concept. Okay, then the next concept is solution by optimization. And you know, here also you have to do a little bit of hard work. Okay, but the underlying language will do most of the work for you. So you should just, sir. Virtual thread will take care of the concurrency. You are saying asynchronization. Yes. Yes, virtual thread will take care of this. Okay, I have not showed you the demo because my time is very less, but see, here is the demo, right, where I am sending the thread for a sleep of 1 millisecond. Okay, and now what will happen if I'll run this code and I will see the compute CPU monitoring. In the virtual thread, you can see the pressure is too less because the thread will go and the thread will see at the time it will see the sleep, the asynchronization code will come out. Okay, it will not block the code. Okay, sleep is actually a block, right? You know, thread.sleep is a block, right? Yes. Is the time over? Is it? Yeah. Okay. Let me finish it fast. Questions we should discuss on lunch. Okay, few of the things which I really very close to, and Firoj is here who work on all these things. So the garbage collector optimizations, if you are all from industry, you know what is garbage collector. JVM do a lot of internal optimizations like the runtime optimization. It takes care of all your shit code and it will optimize it inside. Okay. So some of the GC performance which we are putting, right? So you can see like if you are moving it from the older JDK to the newer JDK, you can see there is a boost in the performance, right? And that we always say like you should always be onto the cutting edge technology of everything. Okay. Fortunately or unfortunately, Java don't force you to come onto the JDK 17 or JDK 21 or like that. But if it is your operating system, they will run your auto update and they will tell, no, you cannot stay on this. If you are using Python, where most of the people know that it will break into the next release. Okay. Unfortunately, Java is actually it's a fortunate thing for many. Java is the only language which can support the backward compatibility. And it supports till JDK 1. Actually, we have still so many jars who are sitting on like JDK 3 and JDK 4 and like it's from the legacy of the grandfather to the children and to the grandson and like it's going on. Okay, and the jar is running perfectly fine. Okay, but if you are doing the fresh development, you should always use the latest of the technology. Okay, so throughput, you know, latency is also very high. You can see with the newer JDKs. Okay, pause time also you can see with the newer garbage collector. The pause time have went very down actually. That is like 0.1 millisecond. That is the pause time we are looking out. Okay, definitely the memory usage will increase with the newer versions of JDK, because whenever you try to reduce few things, the few parameters will go up. Okay. And the last thing which I want to discuss is solution by infrastructure. No one likes that. If you will say I will increase my infrastructure, I want to improve my infrastructure, let me tell you clearly, no one is going to listen that. Okay, so never give that as a first solution, that I need more heap size. That is what the industry do, right? I mean, if the JVM is going out of memory, they will go and increase the heap. It don't work, right? So this is the typical workload these days we are seeing, like in the Kubernetes pod and kind of Docker pods. And you should create more replicas of those pods rather than going and increasing the heap size. Okay. So yeah, fix of the perf issue, increasing heap size. No one likes it, but all do it. Okay. Increasing the number of replicas, no one likes it, but everyone do it. Okay. Use another stack, means go from the Java language and use something else. No one likes it and no one do it also. Okay. They will stick with whatever the programming language it has been written from the ancestral property. Yeah. And as one of the persons said here, the load balancing. Can you raise the hand, sir? Yes. Load balancing is very important thing. And load balancing happens that who is paying you more money. So you should balance the load as per that. Okay. If there is a highly paid customer, you will give more bandwidth to them. If there is a less paid customer, you will give less bandwidth to them. Okay. So depends upon the here, though I am not talking of the bandwidth, I am talking about the JVM size and replicas, right? So there are two topologies that you can take, more small JVMs, many replica, or larger JVM, less replica, depending upon what suits good to your application. Right, so you have to do a go work. Right, I am on the last slide. Scaling is one of the most complex problems of the industry. We cannot give extra resources, whereas we cannot afford downtime also, right? Amazon claims 1 millisecond downtimes claim them $5 million US. Okay, 1 millisecond, I'm not saying 1 second. I mean, how much we do shopping, it's ridiculous. Scaling should be part of all software lifecycle phases, okay? Profiling, monitoring are very important when you are doing a scaling up your application. You cannot just sit on the theory and can do the scaling, right? Scaling may give you a worse result than what it was giving now. And a few examples I have talked, like Twitter I have told, there are many other examples, okay? So you should look for the scaling examples, okay? That's it from my side because we don't have extra time, so I will not go for more codes and shows. Any question, I can take it now. Last question. Yeah, this is what happens. I will give you the resource and it will be of no use, just like that.
So,
okay.
Let's say virtual thread. We are using the virtual threads, and then we have some other dependencies as well. So will we be able to use the virtual threads with the same dependencies, like let's say some other jars we are using to connect to the database or stuff like that. So will they be able to take the advantage?
No, they will not. Virtual thread is a API level change. You need to understand it's a API level change. If it's a jar which is already made up of some code, where it's written thread, not the virtual thread, it will run with the normal classic thread model. Okay, so you take that jar, you get the class out, you take the code out, you make the class again, you make the jar. No, you should not do it. Okay, so it cannot leverage that jar. Okay, so new development can be done, but the old developments, old jars thrown somewhere, it will use the same classic model.
So kind of, let's say, we are using the dependency to connect to the database, the example I'm giving. So there has to be some development and the new version has to come up with...
Exactly. When actually application developers are the last people. So it starts with the operating system language, then the third party tools like you are using JUnit, you are using some kind of other jars, right? The third party jars. You are using a Spring Boot jar. So those guys first need to actually use the virtual threads. Okay, and then it's your application who has to use it. But I can assure you that application servers, framework developers, they always use the cutting edge technology. Okay, they will, most of the Apache Lucene, Apache Tomcat, Hadoop, they all work with the latest Java. I know that much. Okay, and they use most of the latest technology by API also, not just by the namesake. Okay, so yeah, it's the time for the application developer to look into the problem.
And one more question is, from which version is this coming? Like the virtual threads are being going to be available?
Okay, from JDK 19, the virtual threads are there. It will be production ready in the upcoming JDK, maybe a 6 month or a year time. The Oracle tell me not to tell the time, so it's fine. I mean, it will be ready.